Let's see. I'm trying to think how I'm going to do this though, because I've got to sign into my email. All my stuff is on Google Chrome.
Oh, but you can't access Chrome. Is that the
But well,
issue?
if I try to go, I'm on Firefox on this meeting, but I'm trying to access the screen on Chrome, and I don't know if it's going to let me do that.
If you share your screen, you should be able to just select which window you want to share to. So you could just share to the Chrome window.
Right, but like, how would I? Because I got a double screen, and one's on Chrome and one's on this Firefox. Um, Let me try this. Can you see that?
Yes, we can.
Okay. And if I go to slideshow, can you see the big slideshow?
Yep, looks great.
Okay. Okay. It's weird because I'm like flying blind here. Sorry about that. I can't see
No,
anything on the other screen. So,
but yeah,
all
that's
right.
challenging, but it looks good for us.
Okay. Very good. Okay. So thanks everybody for joining. I'm going to go over some of the flood inundation mapping that we've rolled out just about 2 weeks ago across the remainder of Vermont. And I'm going to go over a lot of the how we're doing the FIM, some of the new FIM that's going to be coming, a little bit of the science behind it, and then we'll go into the different categories of FIM on how you can visualize it. And I can even take you through a walkthrough online on how you can get to it too. I kind of show you in the slides, but anyway, thanks for joining. Let me go ahead and move on. Here is the agenda for today. We're going to talk about the importance of FIM. I'm just going to say FIM, flood inundation mapping. Hopefully everybody can understand that just for the sake of brevity. I'll do an overview of the FIM services that we provide and some of the science behind that. Then how FIM and what we call IDSS, Interactive Decision Support Services or decision support works, how we envision talking with planners, emergency managers, etc. When we talk about these FIM maps, and then finally some tools and resources for you guys. I would say I've given presentations to about 10 to 15 groups across both states, New York and Vermont, over the last 6 months. So a few of you may have been on one of those talks. I'm not exactly sure. There may be some cross I don't know what the word is, but anyway, let's go ahead and move on. So let's talk about the importance of FIM. It's basically going to transform the way or enhance the way we communicate flood impacts. I'm sure many of you have seen a FIM map before, like if you're looking at the FEMA FIRM maps or a USGS inundation map. So it can strengthen efforts to protect our real core mission of the Weather Service and NOAA, which is protect lives and property and enhance the economy. That's kind of our mission, so to speak, in the public safety realm of that. So there's kind of a before versus now on how FIM can help out. This is one example. This is a nursing home in Houston, Texas during Hurricane Harvey, which if many of you recall was a really devastating event. They got 40 to 50 inches of rain in Houston. A lot of places flooded that they never thought would flood there. And so in this case, this was a nursing home and some poor people got caught in floodwaters and eventually had to get evacuated. Nobody passed away at that residence, but they were unprepared because they didn't know, the directors of the facility, that they were in a high hazard floodplain. But now this other type of maps and this FEMA coming out in the right hand during the passage of Ian, people were looking at some of these FIM maps from the emergency planning side of things, and we're communicating with some of these residents, and they were asking to be evacuated ahead of time based off of what some of these FIM maps were showing. So that's just kind of like one idea that it could be applicable in this case. So essentially, it's just putting water on the map, right? We're showing where we think the high water is going to affect in certain areas. So let's talk about the overview of FIM. Let me talk about some of the science in front of it, and then we'll get into how the kind of the categories and the flavors of FIM you're going to be able to have, and how you're going to be able to view it. So all of this is coming out of what we call the National Water Model. The National Water Model, it's a continental scale operational hydrologic modeling scheme. It's been in development for about 12 years or so. It's enhancing our flood forecasting capabilities. Provides high resolution stream flow and hydrologic forecast across the contiguous 48, lower 48 states, Hawaii, Puerto Rico, and Alaska. It provides real-time and forecast data for flood forecasting, water resource management, and modeling. And the key outputs here are stream flow predictions, think CFS, inundation mapping, and flood forecasting. You can see there's kind of a crude map here, but I'm going to get a little bit more into the depths of this as we go out. So it's a huge rollout, and it's a massive amount of data and computing resources. So we rolled it out, or are continuing to roll it out in tranches over the last 2 to 3 years. So the southern part of the state, some of you may be familiar, they rolled out with these services in Bennington and Windham counties back in fall of 23, so 2 years ago. And that's kind of what we call the 10%. And that was, again, 2 years ago. Last year, we rolled out up to the 30% level. So that incorporated maybe more of New York and some of the Northeast, as well as a lot of the Ohio, Tennessee River Valley and the Mid-South, and then some of the Pacific Northwest. We're in the 60%, so we just went live a couple weeks ago. And then the 100% will go out next year. But for the state of Vermont, for our purposes, we're all live now for the state of Vermont. So there's evolving water kind of capabilities that we're getting here, right? So all the way up to when we rolled out these water model services, we already had forecasting on our rivers and certain large streams, right? So the left map, you've probably gone to a similar interface. This is our current one, the National Water Prediction Service site, where you can click on the river gauges and see the flows. That was about 3,600 forecast points or river gauges around the nation where you can see that data. As you go to the right, the water model is going to produce these flows for 3.4 million river miles. So you got to think all of these little small streams and creeks, most of which are ungauged, they're producing flow forecasts for and inundation maps for. So it's a ton of data that's going in there. So how do you do this? Because most of these streams are not gauged, so we don't have a USGS technician going out there and measuring a rating curve, a gauge height versus CFS flow relationship like they do for the forecast river points where the gauges are. These are just points around the nation where you have a creek. So they do that through something called the hand method. It's the height above nearest drainage method. So basically what they do is they take a digital elevation model. In this case, most of it is USGS LiDAR data. And then they convert it to a regional or a relative elevation model. And they do a lot of kind of calculations through what they assume the channel fall weg is. And basically they recondition this relative elevation model and they develop these grid-based cells. And then they map out the relative elevation of each cell versus its neighboring cells. And they can route the water downstream that way. That's how you kind of have to do it. It's sort of on the crude side of the scientific methodology. There are some assumptions you make with the Manning's equation and the St. Venance equations when we do this. But it's the way you kind of have to do it because you don't have a measured rating curve and you don't have a gauge there. There are improvements coming along the pipeline, and I'll get into that in a minute. So as I go to the next slide, this is kind of how you have to do it. You have a LiDAR data set, and it basically converts this to a relative elevation model by gridding it out, finding how these cells on the LiDAR data are on the based and relative to each other elevationally. So then you kind of normalize that all to a group of cells. And these are like 100 meters square, I believe. I think that's the resolution on that. And then once you normalize it all, then you can route the water. So zeros are the low points, and then 1 is above that, and then 17, 18, 19 are the high points, and then that's how you route the water downstream. There's a lot of assumptions made when doing it this method. It's not as detailed as like a HEC-RAS model. or a ripple model, which I'll show in a minute. But it's a way it gets you at least a baseline calculation of what the flow is going to be. So through this process, it develops synthetic rating curves. It's pre-computed at half-foot intervals for each reach. There's a couple things that you have to keep in mind, and there's going to be good and bad with this. So it doesn't update dynamically with changing river conditions. So you get a big July 23, July 24 flood that blows out the river channel and changes the geomorphology until you get a new LiDAR data set from USGS or some other, contractor. You can't update these. It's what you have. But that's how you do it. The other thing too is they're building in other things like ripple HEC-RAS modeling and green LiDAR that's going to be able to show the channel thaw wegs better. Right now, the hand method doesn't show the thaw wegs as much. So it tends to, when we start looking at these FIMs, there's going to be a tendency on these earlier versions of the water model to maybe over-predict slightly at like the action bankful stage and maybe minor flood. And then it catches up and is much better at moderate and major flood, which is when it really counts. But there's constant updates to this water model. There's a new one coming out next month, and I'm going to talk a little bit about that, where there's more and more improvements all the time on how we're getting to these things. But a lot of work still needs to be done. But the beauty of it is you're going to have flood inundation for places that you've never had it before. So there's advantages and disadvantages. So advantages, computational efficiency. I'm not going to touch on all of these. You can do it for the whole nation every hour. So you can scale it down to these local levels. It normalizes the terrain through this hand process, so you can route the water in a predictable way. Improve flood prediction. We've had that. So you're going to, this is not going to replace our flood warnings and certain levels of FIM that I'm going to show you, but it's going to build on that, and it's going to be one other layer you can look at, one other piece of information that you can compare. And the way by doing it through this hand method is you build consistency across different regions of the country, whether you're doing this in Utah or Vermont or Mississippi, it doesn't matter. There are some limitations. I spoke a little bit about the missing bathymetry that we're working to improve right now. Most of this is being done at the National Water Center, which is where they do all the GIS and flood inundation mapping down in Tuscaloosa, Alabama. A lot of really sharp people working on this. You're making some assumptions in these synthetic rating curves. There's some exclusion of hydraulic structures. So for example, yes, it takes into effect the Waterbury Dam and the Wrightsville Reservoir Dam. Of course, those are big structures, but John Doe's Pig Farm Dam up in Lamoille County somewhere, it doesn't have all of that in there. And so we have to keep some of that in mind. And somebody asked me on one of my sessions, what about, does it take into account beaver dams? Because sometimes we have beaver dam blowouts and localized flooding on streams. No, it doesn't take into account beaver dams. Those are, kind of akin to like trying to predict where a lightning bolt's going to strike. You don't really know that. We do have some catchment boundary issues in a few places. And a large scale, think about how they levee the Mississippi River and build levees. Some of that can be very complex on what floods and doesn't flood along the Mississippi with levees. And it doesn't really address water body inundation. So while it understands what the flows are going to be coming out of Waterbury Reservoir, because that's taken into account on our Winooski River flood forecast, it doesn't really map up behind the Waterbury Reservoir, because those levels can change based off of what Green Mountain Power and the state want to regulate that for. And that's, during high flows, that can be done on an hourly basis. This model's not going to do that. So you just have to keep in mind that. There are a lot of new mapping techniques coming. It's really exciting. The catchment boundary mitigation is going to be, they're reducing some of those biases. They're doing a lot of AI work to estimate better rating curves on a lot of these streams. And they're using some more optimized Manning numbers. It's a little too complex to get in for the sake of this talk, but Manning's equation is one of the baseline equations that helps drive routing down a stream. And in that equation, they make a lot of assumptions anyway, but they're enhancing some of that. And then they're starting to apply these regionally applied ripple HEC-RAS flood mapping, which is even higher resolution than the hand method. So touching on the ripple map libraries, it uses these basically these higher degree river models to make a water surface elevation map and flows for each half foot of the rating curves in that system. And then so they take the map for each step and then they replace it in the flood inundation mapping libraries in the water model and then replace that for where the hand is. They're in testing right now. They're going to be rolling these new methods out for portions of our area. It's going to have a more accurate method for map generation. There's still some problems with some of the bridges in the mapping. So think of how a bridge, the approaches to a large bridge across a river are lower than the bridge span itself. So, you know, if an emergency manager will ask you, well, is the bridge going to be flooded? I can tell them, well, it looks like the approaches to the bridge will be flooded, but I'm not confident that the span of the bridge may be flooded. And some of that can be very tricky. You know, if you're on a barrier island in North Carolina and you have a storm surge coming in from a hurricane and you need to get people off the island, it's all relative to when the bridge is flooded, right? Once that bridge goes under, you can't get those people off the island. So those are complex issues and they're working to heal that, but there's still some issues with some of the spans of the bridges. So here's where some of the planned ripple HEC-RAS areas are going to replace the hand method in the new version coming out next month. A lot of our northern New York rivers, the Lamoille, and then down in southern Vermont, the portions of the Connecticut here, and then down into Bennington County, Battenkill, Walloomsac, and the Hoosick, down there through Bennington and Manchester, will have these new methods applied. And they're constantly looking at biases and where they can improve it and what the skill scores are of the model coming out. Again, some of these are going to be on gauge streams. Some of these are going to be on just little creeks. So, you know, we'll continue to improve that. So let me move into a different portion of the talk because this is probably the most important for your purposes of what you can see and what type of FIM you can see right now. I do want to mention that you're going to have access to private FIM libraries through API and web services that not everybody can see, but the stuff I'm going to get into that in a minute, but this stuff I'm going to talk about right now, the public can see it too. I'm not briefing anybody or giving presentations to the public on this because I think it would only confuse them. The talks I've been given to more like groups like yourself, river floodplain management groups, and people involved in public safety. So RPCs, fire departments, police departments, things like that that are familiar with the flood inundation in their town. And there's no expectation that this is all going to be perfect, right? If you're a long time fire department official or EM in some county or town, you probably already have a broad knowledge of where it's going to flood when a river gauge gets to this level. But you may not know what's going to flood on some creek. So this is where a lot of this can come into advantage. So there's two different broad flavors of FIM, static FIM and dynamic FIM, okay? So static FIM are FIM libraries that never change, static. They're always there. They don't change unless we, you know, physically update them at some point, and then they won't change again until we update them again. There's two flavors of these, and we're going to get into all of these. We have partner FIM libraries. This is the gold standard FIM that's developed through high resolution FIM libraries and LiDAR data. There's a limitation that there's only a few points in the nation that's available for. We're lucky that we have 9 in our area, and I'm going to show you about these. Then we move to these categorical FIM ham libraries. Categorical, think floodcats, CAT. So where we have gauges and where we have flood impacts that are forecasts. This is called categorical hand FIM. So this is 30,000 river mile reaches. This is where, you know, these are the big river forecast points, Winooski River at Montpelier, Otter Creek at Center Rutland. This is where this static FIM is going to be able to be available at. Then we have this dynamic FIM. Dynamic FIM is what's changing. So think of this as being available when we have high flows and it's changing constantly. So you're going to have National Water Model 5-day max forecast. This is for all 3.4 million miles of streams, creeks, and rivers. You're also going to have the River Forecast Center FIM. So when the River Forecast Center puts a FIM or a forecast out for the Winooski River at Montpelier, you're going to get the FIM for that. And then you're going to get the hourly water model latest analysis that run every hour. These are dynamic, okay? And I would mention here, and I may mention it again in the talk, these are available to the public for anybody to see, but they're only turned on, these dynamic FIMs, when we're in high flows. Due to computer resources, they're not going to run this for all 3.4 river reach miles in the nation. So we're in a drought right now. You're not going to be able to see it. Where the access point is, and I'll show you, it'll just be grayed out. You won't see whatever it is. You'll have to go to where high flows are. So think of when we're under a flood watch, if there's high flows or we have ongoing river flooding, that's when it's going to be on. Okay, let's dive into the details about the static FIM. Remember, static, dynamic. Static's always available. So let's talk about the partner FIM static. So it's the highest quality static FIM. It's using engineering grade modeling. It includes depth information, often unavailable in a lot of this other FIM. So when we look at a lot of this other water model FIM, it's going to show inundation, but it's not going to show how deep it is. This partner FIM will show how deep it is. The forecast locations are carefully selected based on flood impacts, data accuracy, and also whether a town or a community had money to develop this. And it can help validate the dynamic FIM. If the dynamic FIM is way off, then I would be very careful around a partner FIM site, because the partner FIM is pretty much the vetted out good stuff. But it's good for us. We actually have 9 sites. We have 7 on Lake Champlain, and then we have Waterbury, Montpelier. And if some of you know, the Waterbury Montpelier partner FIM has been available for 5-6 years. It's been available off our old platform. It's on our new platform now, and I'll show you how to get to that. So if you go to the Waterbury, and I'll go offline after the presentation's over. I'm going to show you how to get to it. I'll take you through a tutorial real quick. So you click on Montpelier or Waterbury, click on, then this little gauge page pops up, then click on the full gauge page, which takes you to the big expanded hydrograph here. Once you click on that, and then right down here by the red arrows, click here for Montpelier or Waterbury partner FIM. And that's how you get to the partner FIM for Waterbury and Montpelier. So this is what the interface looks like once you click on that. So you have 2 tabs at the top, Waterbury and Montpelier. Doesn't matter which gauge you go to, it'll take you to the same page. And then you click here for transparency, and then you just turn off your levels. Now the way, excuse me, the partner FIM was mapped, pulling off the digital elevation model, it's not mapping, as you notice, to exact, nice, clean, easy foot increments. It's not all like 22 feet, 23 feet. You see like a 21.7 feet and an 18.6 feet. So for ease and understandability, we put in parentheses what minor, moderate, and major flood stage are in Montpelier right up here, 17, 16, 15. And then you pull them off down here. It's the standard stuff, right? You go to the little tiles and change your map projection. You want to see street view or Google Earth versus a street map. And then you just zoom in. And so this is where I've turned on 21.7 feet here at Montpelier. This is roughly the 2023 flood height. It's pretty dang good. You know, it shows what flooded in downtown Montpelier and things of that nature. And you can play around with it. We vetted a lot of this. Again, it's not 100% perfect, but it's pretty good. And I would also mention on a lot of these FIM maps, there is a limitation. So like for the partner FIM here in Montpelier, I can't scroll, 20 miles upstream of the Winooski out of Montpelier. You get too much above where like the Route 302 intersection comes in, and then that's the extent of where they map it, because you're getting kind of far away from the gauge site. So there's kind of a limitation on how far you can see it. And you would do the same for Waterbury. If you want to do this, you can play around with the transparency, the projections, and the stages. Click on Waterbury, and you would get the same thing. So that's the partner FIM that we have available online for Waterbury and Montpelier. You do it a little bit differently for the lake. So for Lake Champlain, we have 7 sites, 4 real, and we have 3 virtual. So they're not real gauges there. It's just a virtual FIM site. So I've clicked on one of the gauges. I can't remember which one it is here. The Sandbar State Park FIM. There's no gauge there. So when you first click on it, if you notice in the circle, it says hydrograph unavailable because there is no gauge there. But you get about it in a similar way. You click on the full gauge page, which would theoretically blow up the hydrograph. And then a little bit different, you scroll down on the page below where the hydrograph would be, and there's a map of where the gauge is. In this case, a virtual gauge. It's got your flood stage cats. And then right down here, unique local info, click here for FIM display. And after clicking on yes, I agree that some of this is, I'm sorry, excuse me?
Do the backspin?
Someone's mic just turned on. I think we're good.
Okay, I wasn't sure if somebody asked a question there or not. I wasn't sure.
Worries.
Okay. Yeah, so you get, as you can see, the interface is very similar to the Waterbury and Montpelier one, but you just have, you have 7 tabs or whatever, yeah. And you click on the one. And this one I've clicked on Whitehall, I believe New York is an example, and you get your depth grids here, color coded, and you play around with your transparency and you zoom in and see what's flooded on the lake. So, the lake rises and falls very slowly. So this is clearly more for planning purposes more than like maybe evacuations in Montpelier if it was going to be that way. But you do have this available for all the lake if the lake in the future gets really high. I would mention that our partner FIM that's developed through USGS, and then for the purposes that we're displaying on our maps on the Weather Service, that's not the only partner FIM. Of course, big cities like Houston and New York City have their own FIM maps. It can be really challenging if you have a lot of these FIM maps out there. Here's an example from some other USGS-derived external partner FIMs in Western Massachusetts. I think this was for a river group out there. These are not shown on our map. These are hosted on some other site. So sometimes we run into that. I know for a fact when Hurricane Harvey went into Houston a number of years ago, they were trying to compare multiple FIMs from different constituencies, river floodplain groups in the city of Houston, and there's a levee authority down there and stuff like that. And it can get really complicated when you're trying to compare all these things because some of them are elevation models and some of them are inundation and some of them are depth. And, the fire chief calls you and wants to know which one to use. That's a complex thing. So, just be aware that there are a few, and you may be aware of a few others that may be out there that we're not hosting. The other one on the static is the categorical stage-based FIM. Important here, remember CAT meaning flood stage. So these are at official forecast point locations only where we have flood stages established. They're going to be available at 1 foot increments, including our flood categories. And so this can be really good as well. If you want to, if you're not in Waterbury or Montpelier on the lake, but you're in Rutland, this may be the best thing you can go maybe to refer to because it's mapping into the CAT levels, and I don't have partner FIM here. There are some limitations. We have the ability here, and I have the ability to turn it on and off of where I think it's good and not. And I've got a list of points right now that I'm getting ready that it's going to be available or it's available for. Other points it's not because I don't feel confident that it's good enough, and I don't want to mislead anybody to show something being inundated when it's not. Remember I told you on some of the water model inundation that it can tend to overpredict at minor levels in some cases. There's some gauges that it does that. And so I've turned it off right now until we get better updated versions of the water model that'll hopefully improve that. So that's one limitation. It's not going to be available for every single forecast river point. But we're finalizing the QC, and once a new version comes out, we'll QC it again. So how do you access CAT FIM? So you click on a gauge where it is available. You click the full gauge page. Again, remember it blows it up into the bigger hydrograph. Very similar to how you do it on the lake. You scroll down to below where the map of the river gauge is, and right down here you can click activate, deactivate, partner FIM, CAT FIM. Partner or CAT FIM in this case. So this is an example for Otter Creek and Center Rutland. I do have it turned on there. And so you play around with this. There's an interface. If I go back here to the other map, once it displays here, it's going to display the cat levels on the right of the map. And then here's where you turn off the levels right here on your left menu. My next slide I showed you is just a zoomed area, but this is kind of how you see minor, moderate, major, record flood stage for Rutland. I've got it turned on. Again, it's not perfect everywhere, but it was good enough in most cases based off the impact statements I have for the flood stages at Otter Creek to see this. There's a few, it's always complex with FIM when you're mapping stuff. There's always potential backwater effects that something could back up in some of these creeks. This left-hand circle, this is the Clarendon River that comes in near the gauge. Some of the FIM right along the gauge here, well, there could be some dependency on how high the flows are coming out of this. This is the East Creek, the right circle, and this is somewhat regulated coming out of Chittenden Reservoir up in Chittenden, Vermont. So if the flows are high here, it's hard to know. And again, remember, this is inundation mapping. So I get people asking this all the time, will this help in flash flooding? Well, it can to some degree, maybe, but I'd be very careful. That's run off of only the water model stuff, and it's hourly precipitation data that's getting ingested into the model. And if that's not that good, then the water model won't do that good. So I take, for example, just kind of taking a step back, if you remember the July 30th floods last year up in Lyndonville on River Road, that was a very, from a broad perspective, localized severe flash flood event. The models didn't pick up on that until almost it was in the middle of the event on how much rainfall was falling. The radar data was relatively poor. And we did issue flash flood warnings because we have other tools to look at. But in reviewing the water model data for that event, it wasn't that great for that. So you have to kind of take into account some of these localized little flash flood events. I'd be careful on that. Think of like broader scale Irenes, flood of 24, flood of 23 in July's, something like that. The December 23 snowmelt event, I'll get into that in a minute. And then you can play around and zoom in. So this is the cat FIM. Again, static FIM, it's not changing. Okay, moving on, dynamic FIM. So how do you access the dynamic FIM layers? Well, you access it through the same platform, the NWPS platform where you've seen before, you click the river gauge. But in this case, if you are familiar with the page, you have all these right-hand menus you can play around with. You come down here and you click on flood inundation on the right menu, enable that. And then this enables a pull-down menu to be pulled down, and then you click on the 3 FIMs. And remember, so you've got that RFC, River Forecast Center 5-day max forecast at your forecast points. You got your water model latest analysis FIM every hour, and then your 5-day national water model max forecast. Those are the 3 you're going to have. And then these you wouldn't really need to worry about, just Puerto Rico, Virgin Islands that are thrown on there. Again, they're only turned on during times of high water, okay? So let's talk about these 3. So the water model 5-day max forecast FIM. So this depicts the peak inundation extent that the national water model is showing over the next 5 days, where it's producing flows that meet or exceed high water threshold criteria for a reach. So again, think of high flows and heavy rain event coming, we're under a flood watch. It's based on the national blend of models rainfall, so it's a very ensembled model approach. So they take a bunch of models, they tweak the physics in all the models, 60 of them in there, they blend them together, the ones they've vetted out that have the best skill score, and produce a common theme picture of what the model precipitation is, and then it's running off of that. Limitation, you're doing this for broad areas of the country that are under high flows, so we don't have somebody sitting at the water center, tweaking this on every little creek and stream. So there's limited human involvement. The model runs, it puts the FIM out. Of course, they tweak the model and give updates a few times a year, but they're not doing this on a daily basis or an hourly basis. But the strength is it's available everywhere, gauged or ungauged. So you click on a place where this is turned on, you enable the flood inundation on our app platform, you click the max 5-day forecast, and it lights up right here for you on the map. There's an opacity button where you can play around with the opacity down here. And then I think up top is the menu where you change the map projection, whether you want to see a street view or a Google Earth view, and then you zoom in. Moving on, this is the second flavor of dynamic FIM. Remember, we have three. This is the RFC, the River Forecast Center. So this is downstream of the river forecast points. So you think water model everywhere, anything RFC, just at the forecast points. So this is where where their forecasts reach action stage or higher. Limitation, it's only downstream of those points, right? But the strength is on these is it's based off the official forecast points from RFCs. So you got it at Otter Creek, you got it at Essex Junction. You got to cross compare all this stuff, right? So like think about Montpelier. What if I were in Montpelier, what I'm going to look at? Well, I got the partner FIM. That's probably what I'm going to lean toward. But you do have some of these other ones available. So if I don't have partner FIM, but I do have a forecast point like, Essex Junction on the Winooski, I can look at it. Maybe this is going to be the best. Same exact way. So you click on the RFC Max FIM, play around with the opacity and the map projection and zoom in and see what it shows. There'll be slight differences based off of RFC and the water model. And the last one is the National Water Model Latest Analysis FIM. This depicts reasonable inundation extent at the current time. So it's run hourly, get hourly output for everywhere, water model. There is a latency because they're running it for everywhere. So it's about an hour late. So if it runs at the top of the hour, you're only going to get it about an hour later. And that's why I say, I'm really hesitant to get too excited about it now and in these early not developmental, but these early versions of the water model to use it in some isolated big flash flood case, because those things evolve on the time scales of 45 minutes, an hour and a half, 2 hours. If this stuff's an hour late, then you're leaning toward flash flood warning or flash flood emergencies way more than what I can confidently tell you what's being inundated. But it's getting better all the time. So hopefully as the years roll on, there'll be better and better versions coming out. So the reliability decreases in where information cannot be in tune to observed information. Think of like Eastern Vermont, where our radar data stinks because it's blocked by the Green Mountains and you only get so-so estimates of rainfall. Then it could suffer a little bit. On the big stream rivers, it can be better. Again, you get to it the same way. Click on flood inundation, choose your flavor of choice here. In this case, the latest analysis FIM. I've just showed you another way to look at it. It's on a street view map, and the opacity is a little bit higher where it's, it's a little bit shaded in more. So let's talk about strengths and weaknesses. A lot of this is going to be review. So some of the strengths of the water model and the RFC FIM, the dynamic FIM. So you can visualize the forecast and impacts for anywhere across the nation, especially in regards to the water model stuff. It can create a common picture of a river stream flood threat in a given area. It improves the ability to target areas and pre-position resources. Think like large scale on this, a big flood event, like, a hurricane's coming in and you're predicting a big flood event. Like earlier this year, they had some really severe flooding in like Western Kentucky and Southern Indiana, Illinois, Eastern Missouri. Mike Cannon and his flood group for the Vermont USAR or whatever, Urban Search and Rescue Group, deployed out there. And they used some of this to figure out what county clusters or portions of these multi-state regions can we deploy our resources or our positions so we're in better shape. And Mike asks that all the time. We have a flood event coming out, John, where should we deploy? Well, I think it's probably going to be focused on Southern Vermont more, or this is a more northern part of the state. He's in tune to that stuff. This is kind of where you would do it. You wouldn't necessarily, use it on that isolated flash flood, because some of that is kind of a act of God, for lack of a better sense. You're not exactly sure. These things can kind of whack-a-mole and pop up, and you're not exactly sure when they occur. Limitations, extent only. This is not partner FIM, so you don't have, how deep is it going to be on this street? Well, we don't know on that. We just have inundation only. And these are limited before they convert the hand method on a lot of this to the relative elevation models. These digital elevation LiDAR data sets are like 10 meters. That's getting improved all the time. So you got to understand that you can't see small physical features and their impacts on FIM, such as small ridges or bridges or an unofficial levee. So it's not that effective. Let me give you an example. It's not that effective anymore anyway, but on the Linden Trailer Home Park up in Linden, that place always floods when the east branch of the Passumpsic gets high water up there where Route 114 and 5 come in. If any of you are familiar with it, there's kind of an old trailer home park up there. They had built a small berm along the river there to help flood impacts. It's only about 2 feet high. That was never mapped into some of these schemes. So, you know, it doesn't really know that exists. I did some flood surveys notwithstanding last year up there, and that thing has been compromised since. It's not really that effective anyway. And the trailer home park flooded. But some of those small scale features aren't incorporated in. You know, again, another one I had mentioned early in the presentation, like a farm pond dam on a very small scale, less than an acre. Some of that may not be shown as well in some of this stuff on a small stream or tributary. Again, we talk about the simplified physics through the hand techniques. We are moving toward that ripple HEC-RAS-based modeling on some of our rivers and streams. I showed you that. But the hand method per se has to make a lot of simplified assumptions when you're doing this across millions of miles of stream reaches. So there's simplified physics here. Again, the versions of the water model are limited by how, you know, a flood forecast is only as good as what the precipitation you're putting into the model. If that stinks, then the model's not going to be that good. So there's a limitation based off of the rainfall creating the flow. If it's good, it's going to be better. If it's not good, it's not going to be as good. And you cannot adjust or manipulate that rainfall going into the model because it's a running model that's updated. You know, these RFC static FIM maps are updated when the RFC puts the forecast out. And the categorical FIM, that's a static map. It never changes. Some of this is only updated a couple times a day. The water model instantaneous is updated every hour, but there's limitations on that. So it doesn't have a lot of human influence on that. I'm not going to touch too much on the coastal use because we don't really have to deal with that there. That's one of the reasons why they've held off a lot of the East Coast to the 100% rollout, the last of the people that roll out the FIM, because if you think of this in a simplified aspect, a tropical storm or a hurricane making landfall with a storm surge and then high flows coming down a river and where those meet, that's a really complex process to try to say, okay, what's the water depth at that point, or what's the inundation at that point, based off the storm surge and the river flows. So there's a lot of complex physics that go into trying to predict that. Reservoir impacts on FIMs, they certainly can impact stream flow accuracy, right? What's the flows on the Connecticut? Well, that's highly dependent on what Comerford Dam releases or Wilder Dam or any of these dams have their degree of releasing on the Connecticut, or Waterbury going into the Winooski, right? So depending on that, some of the flows into the FIM could change. Now, when we talk about these big water reservoirs like Waterbury and Wrightsville, those are already taken into account in the RFC forecast for the Winooski, and for the Connecticut, for example. But some of these things, depending on the scale and what's forecast for, there could be some dependency on that, good or bad, based off the accuracy of the FIM. So there's several thousand reservoirs represented in the FIM, and they base it off basically level pool persistence, or for the example of the Winooski or the Connecticut River RFC informed forecast. So, but if you have some reservoir on some ungauged, unforecasted stream, you may not exactly know what that is. And some of these reservoirs are hydro operated, but there's not a forecast point there. It just depends on where you are. So finally, as I get toward the end, let's talk about flood inundation mapping and decision support services. How do we envision this? How do we envision talking about this with your groups and emergency planners and public safety officials in the state? excuse me, this is kind of a timeline I like to use. This is kind of from the left far out all the way through the event and after the event. So when you're kind of pre-planning blue sky, days 4 through 7 or nothing's going on, you've always got the cat FIM and the partner FIM. Remember, these are dynamic or static FIM maps. You can always look at those to where they're available. And you've also got your river ensembles that show your flows that are available that I won't really talk about today. Those are just kind of stream flow predictions going out. When you get into the day 1 to 3 pre-flood, think of this as when you're getting into the time where we may be under an excessive risk of high rainfall, or as you get into the day 1 or 2, we may have a flood watch out. This is when you start to get, you're still going to have the partner FIMs and the static FIMs, but then you get into these 5-day forecast FIMs from the water model and the river forecast center at your forecast points. Okay. And then you get to the event and you have everything. So you have all the partner and static FIM and all your dynamic FIM, including the our latest analysis FIM. And then when you get out of the event in your post-flood and recovery, they start turning some of these things off. You may still have some latest analysis FIM, but then your 5-day max extent FIMs may not matter anymore because your rivers are already pulling out of flood, right? So 5 days out, nothing's flooding anymore at that point. And so you're doing high water marks, flood photos, video damage assessments, things like that at that point. So we have a lot of decisions support services that we do here at NOAA Weather Service. Of course, we always have our public services where you can click on a map and see a river gauge, or you can click on our forecast or see a discussion or whatever. And then we have different levels of IDSS. Our baseline IDSS, think of this as like a graphic email. Like you get an email brief from us about a big winter storm coming in or a flood event. Then we have targeted IDSS. This is where we're providing targeted graphics and emails on an individual targeted basis. We do this for the Champlain Valley Fair every year. We do it for the Ironman Triathlon in Lake Placid. I saw your note, Darren, thanks. Yeah, we can get back with me if you need to. So that's targeted. And then on the high impact events, you can be integrated. So like a big event, like an Irene comes along again next year, we integrate into the EOC in Waterbury. And myself, or let's say it's a flood event, one of my seasoned hydro team members, or myself, or Scott Whittier, our warning coordination meteorologist, will be embedded at the IOC. They'll do this we do this for a lot of events around the country. We'll do it for like the Super Bowl or a big impact high event for a hurricane. Hurricane comes into Florida, a big hurricane. They'll have a weather service office, weather service personnel at the state level EOC in Florida to brief in the planning and the logistic, or the planning section for that, because they kind of use those at that point, kind of a an IDS IDC kind of format. So basically, we're just putting water on a map. You know, these are just examples of some graphics we can use in a partner brief. We can show the hydrograph and highlight what that flood stage would mean, and then show what it looks like on a map for a partner brief. And if somebody wants a private chat or something like that, we can share this. You know, I would mention, even though these dynamic and static FIMs that I showed you, the public's going to see, we are not showing this on social media. You know, there is a limitation on the information flow out there. So I have briefed our media partners on this so they can look at that. So if Tyler Jankowski wants to throw something on Facebook, I can't control that, but we're not doing that because I don't want to go down the rabbit hole of lesser informed users getting scared on something that they may not understand. So again, FIMs we're not sharing on social media, only internally through private conversations through email or chat, or through a request from public safety emergency management, people in the know that have an interest in floodplain management, things of that nature. So just keep that in the back of your mind. Here's another way we could do it. These are just examples. Here's a FIM that shows possible inundation of the lower levels of this little neighborhood on the Rock River. I think this is in kind of along the Iowa-Illinois border down out in Quad Cities, Davenport. Here's one they used with Helene last year in Asheville. Horrific event. They were able to share the downtown inundation extents going to record flood. This can be very informational in talking about flood planning and resource planning. I'm not sure if this was a partner FIM or a static FIM or what, but anyway, this is something else that we can share. So tools and resources, I've shared some with Ned. I'm going to share them with Tessa today at some point. I got to go get a COVID shot first, and then I'll be back. But I'll share that with you, Tessa, the resources. But and I'll also share the presentation so you guys have that. But again, here's all the list flavors of the 5 FIMs you can have. There's a lot of other. I mentioned this. There's a national GIS viewer that you can go to down here. This is public as well. You can view a lot of other FIM high water services in this national viewer that I didn't even talk about today. It's got like probabilities of like high water probs and rapid onset probs. You can visualize this through a lot of this, and it's available online to ingest into local GIS systems. I've been talking with John Van Hosen, I believe, through VCGI on some of the mapping coming in. I've had a chat with him earlier in the week about what we want to pull in. So some of this is being able to, you can pull this into your API REST services, and I know John is working on some of that. Water.noaa.gov is just the main, this site here I'm showing here. And then here are some of the web links for some of these services. John is familiar with these, but if any of you else are interested, this is some of the way you can access some of these online libraries and REST GIS services to pull into any other platform you'd like to do. And then this is the link down here. It talks about some of our cloud-based web services, how you can use some of that. Again, I'll send Tessa the link to the presentation, and you can look at these slides toward the end if you're interested. Again, this is a final review, water.noaa.gov, or go to our local page, click on flood inundation, then start to choose your dynamic FIM of choice. If you want to look at the static FIM, remember you got to click on the individual gauge and scroll down and do all that. Again, this is the national viewer. You can see a lot more things in the national viewer. You're seeing tornado warnings and hurricane warnings and winter storm warnings, but all these hydro services are available through the national viewer as well. So that's all I got. Thanks a lot for your time. That took about an hour or so, which is good. I allow for an hour and a half. It always can be shorter than that, obviously. So if anybody has any questions, yeah, feel free to shoot them to me. I can go back to a slide if you need me to reference something, or I can just answer it here. Thanks a lot.
Thanks, John. That was great. Darren put a question in the chat. I think you saw it a few minutes ago, and Darren might have had to leave, but I think it's still a good question for everybody. Who's asking about the interplay between the National Weather Service FIM and FEMA firms, especially as the new firms are now using LIDAR. I think DEM is digital elevation model. So will they show the same inundation coverages? And if so, which would be considered more accurate?
Right. Yeah, that's a big question. These FIMs that I've showed you today are for planning purposes for public safety. They should not be confused with the FEMA stuff. So in no way should they be used. You know how the FEMA firms are, is where you're designated the 50-year flood, 100-year flood, what's defined as the city floodplain. That's what's going to govern your city zoning ordinances and all that stuff. Of course, that's what you're going to use it for, but you don't have those everywhere, right? You only have them somewhere. Now, it's a great thing, right? Because these FEMA firms are being updated. They haven't been updated in like forever. In some cases, the 1970s and 80s. So it's a great thing. So from a city's perspective, you got to be careful in saying, what's the CAT FIM and the partner FIM showing at 21-foot stage level at Montpelier versus what's my 100-year flood? They're apples and oranges. So I kind of try to keep it separate. So the FEMA firm maps are invaluable, but they have their own purpose. This is for more the public safety element of, okay, this is what's happening tomorrow. This is what I can look at and maybe see what I need to be aware of going into the night. So very good question. But I'd have to imagine the FEMA firms are going to be getting better all the time because the LIDAR data sets are getting better, higher grid resolution. And there's something, as some of you may know, called green lidar, which you can see through the river, through the water, and you can see the river channel thalweg and all this stuff. Um, um, and let's see, there's another question here. The state flood hazard, is that associations? State flood hazard.
Special flood hazard areas.
Special flood hazard areas are all zone A, no base flood elevation or other elevation data. Can they be applied to some of these other? Yeah, I mean, I think you can. I think if you have the static FIM and the partner FIM, which are the static ones, if you have that available in any of your area, you could cross-reference some of that and make some, take a look at those and see what they do. Speaking of Dover, I don't believe you've got anything in your area. I think you're mainly on smaller creeks and tribs, right? That's southern Vermont, like Williams River or somewhere down there. So you'd have to kind of pick and choose. Like, if I'm in Montpelier, I'm going to have the new FEMA maps and I'm going to have the partner FIM. I would probably rely on that, and then look at your RFC forecast and see what you're going to. But if you're on the Stevens River in Barnett, what do you have? I don't know if you're going to have FEMA or FIRM. You may not have anything. You may just have the water model output, because there's certainly not a river gauge on the Stevens River in Barnett. And we know back in 24, that was a really bad flood there on the Stevens River. So I think there are apples and oranges. You got to be careful about what you compare, but kind of think of it as this stuff is for the static maps, blue sky planning and reference during public safety, and the water model maps that are run dynamically when we have high flood. Think of that as strict public safety stuff on what we can share with you on.
Oh, Rebecca, you're muted if you're speaking.
There you go.
Thanks.
There you go. I thought I had clicked it, but I guess I hadn't. This is Rebecca Pfeiffer at the State Floodplain Office. I think this is a question that Tabby put in the chat, that probably a lot of people are always looking for a resource to try to provide elevation data for their local floodplain regulations. One of the things that we anticipate with the new FEMA maps is that even though you might have a zone A, we will still have some approximate base flood elevations that people can work with. I think it's that what's in between time, and so I think the big thing is just to realize that, kind of like what John had talked about before with the 100-year flood stage, the 1% annual event, and how does that compare to what the FIM might have from the Weather Service, and making sure that it's kind of like what's best available data. So in some cases that could be best available data, or it might not be. So just trying to use the tools that you have, but it's a challenge in a lot of places where we only have these A-zone maps.
Yeah, no, that's a good point. And I would also mention, I didn't cover it in this talk because it's an internal thing only, but when I was vetting out the categorical FIM for the gauge points, because I was saying you have to see whether it's good or bad on whether it's inundated. One of the things I looked at is there's something called the National Water Model Retrospective Probability FIM. And so we went back and what they did is they took the water model, even though it's been only in development 10 years or so, and they reran it all the way back 30 years. And they gave retrospective 2-5% flood probabilities, 50, 100-year flood probabilities. We can look at those, and then I vet what some of the FIM is showing now, because if that's really off from the FEMA maps, then I have to be a little careful, because you would hope that the FEMA map 2% lines up with what the water model 2% would say, or at least close. And that was kind of the driving force in addition to just some of the flat inundation that it showed, was a big factor in where I turn this CAT FIM on and off and where you're gonna be able to see it. But anyway, no, it's very important. And I think, I've had a lot of these questions on the FEMA firms versus this FIM, and you've just got to be a little careful. And if you're in a big city like New York City or, wherever that could flood with surge, as a hydrologist like myself, or even somebody like you, Rebecca, or somebody could come to you and like, okay, I got these 4 FIM maps. What do I use? Like that's a challenge. You have to have a really thoughtful conversation with those planners and public safety officials on what's your best take on that. And it's not an easy answer all the time.
Does anyone else have any questions? Either put them in the chat or feel free to just speak up. We have some more time in case anyone wants to look at it, go back to a slide.
I mean, I could show you a tutorial if you'd like me to, just how to get to it real time if you'd like me to do that. I mean, I showed you the slide, but maybe me showing you would make it easier.
Yeah, let's do it. That would be great.
Okay, hold on. Let me, I'm still sharing my screen. So let me, and I can't see anything I'm doing other than what the screen. Can you see the weather service map there now?
Yes, we can.
Okay, okay. So weather.gov, right? Click on Vermont. So, and some of this is going to be old hash for a lot of you guys. So click on rivers and lakes up here. And this is going to look familiar to you once it loads. Okay. So let's first go to partner FIM. So remember Waterbury, Montpelier, you scroll into Zoom. Let's click on Montpelier. Remember the static FIMs, you got to go to this, the gauges where you click on the gauges. Go to click full gauge page on Montpelier. And blows it all up. By the way, you do have National Water Model guidance here. For the sake of it, you can click on that, and it'll take a minute to plot. Hopefully, I'm kind of getting sidetracked here. It loads, and you can turn on all these medium range and long range forecast of the water model. See how it, and this is just giving you CFS way out here. See that? So it's thinking some rain's going to occur in a few days. But I digress. You can see that on these tabs up front on the full gauge page. You scroll down and see this, click here to display partner FIM. Continue. And there's what I showed you. So let's just zoom in and I'll kind of try to recreate what I created for you guys. So I click down here and let's go to whatever.
John, one question I have, you might have gone over this, is there a list of all the forecast points that have partner FIM? Because they don't all have it, correct?
No, what I can do, well, it's in my slides. I showed you that.
Okay.
But there's not like a list. What I'll do is I'll email you those, and you know what I'll do too, is I can email you the current CAT FIMs that are turned on in Vermont. But just understand that we're constantly vetting new iterations of the model. So some of those may be upgraded later. I may not remember to send you when we upgrade, but yeah, you just click here, click transparency. Let's go to 50%. And I think it's defaulted to turn on the minor flood stage. Let's go to 21.7, which is close enough. And then you zoom in and can play around with it. It's not perfect. You see, here's the high school that all went under. Access to that. Bailey Bridge, impacted. Here's the thing on the Bailey Bridge and some of these things. Remember I mentioned some of these FIMs on these bridges. If somebody asked me, is the whole bridge flooded or just the approaches to the bridge? And I'd have to say, well, I think it is. It's showing it is, but bridges have spans, right? So you got to be a little careful. But this was pretty accurate. Like if you look at the State House steps at 21.7, it came pretty decent up here. It didn't flood. This sits up on a hill pretty far up. It's not going to flood that ever. But certainly down on State Street and down in these office complexes down through here. So that, and then you would just click on Waterbury immediately because it takes you to the same place, and you click on Waterbury and you do the same thing for Waterbury. And you see how it's got the extent reach. So if you go past North Duxbury on the left up here, or up past wherever this is, up toward Middlesex, that's the extent of the reach. They don't, because you have other tribs coming in and they don't want to map any much further than that. Okay, so that is that's Waterbury and Montpelier, and then you'd get to it in a very similar way on the lake sites. So when you look at the lake sites, there's 3 that are grayed out: Plattsburgh Bay, St. Albans Bay, and Sandbar. Those are the virtual gauges. If I click on those, there's nothing there. So if I click on that, and I go to the full gauge page on Sandbar, again, no hydrograph. But if I scroll down under the unique local info down here, you get to it in a little bit of a different places. Please click here for the FIM display. I click continue. On this one, this is saying it gives you a little flood inundation mapping planning only. There's some zooming limitations for Burlington and St. Albans Bay. This gives you the mapping extent, and then you just click on what you want. So if I go to Sandbar State Park, it's just going to look the same way once it loads. There you go. And you can play around with transparency and map projection and see what. If you go to, let's go to 1028. This is, by the way, this is another cold can of worms because people go, well, the peak stage in 2011 was 103.1. Well, now we're on a new datum. So the peak flow all time is 1028. And you can see how the causeway is impacted out here going out to the islands. Okay, so that's your partner FIM. So let's go back to cat FIM. So let's go to Otter Creek, Center Rutland, cat FIM. This one's even easier. Once it loads the gauge, I click on Otter Creek. I click on full gauge page. Takes a moment to load. And then remember, you got to go down to the map on these. The other ones were kind of below the hydrograph. Go all the way down to below where the map is going to be. And this should load. Let's go ahead and do satellite with labels. For some reason, it's not loading, but come on, you can do it. It's taking its good old time. And then here, see this? You can actually display the FEMA layers on here too. You can turn on the FEMA flood hazard layers if you want to look at that. But here's where you activate the partner FIM. Play around with transparency, and let's just go and turn all. For some reason, they're all turned on. I guess they want everybody to see what's available. Let's turn all these off and look at what record flood is. So you can see and paint around. There is zoom limiting capabilities on a little bit of this, on what you can zoom in. And this is why if we were in a big flood stage area and a public safety guy want to go, I want to really know, like right by the pump house, what's flooded. Well, I may need to go into my private platform and do a really zoomed in screen grab of this. But this is what the public can see. And you can see it maps all the way up through East Creek. And here's some of these, there's a lot of urban flooding issues in Rutland when you get heavy rain. It does not take into account that, right? So some of these areas going down, I think off of Route 4, I can't remember down here. Maybe there's some streets down in here that get bad flow, get all inundated. It's bad, it's poor flooding. It can under inundate. And here's a case right here. So this shows major flood stage. I know for a fact on this cat FIM that up on some of these backwater effects, because this is an individual creek. Remember I told you it struggles a little bit. Some of this area will definitely flood on that. So you just got to be careful on what it is, because like if you look at record flood threshold, let me just scroll back up here. Major is at 12 feet for Rutland. And I just updated the impact statements for the gauge last year working with the town. And some of this stuff, yeah, Meadow Street and the recreational fields will flood at 10 feet, which is moderate flood. And this is showing, well, this is Meadow Street right here. So see how it's uninundating here? So this is where you got to be careful where you're measuring partners. But when I looked at it from an overall perspective of some of the other impacts we had, I thought it was decent enough going up through here. So again, that is your static FIM layers, partner FIM and cat FIM. So if you want to go, let me close this out. If you want to go to dynamic FIM, remember it's only turned on where it's flooding, and it's been so dry everywhere. Like where is it flooding? So let me zoom out and hopefully it'll map somewhere. Maybe we've got some flood inundation down here. This is tidal. Let's see if we've got it here. And in fact, I don't even need to turn the gauge on here. Let's, a lot of this is tidal, but where you would get to it is right down here. Let's go to satellite. Let's turn that on. And then let's scroll down here and see, here's the flood inundation. So you enable that. And then once you click on that, then these become active. So then I click on that and then you zoom in. And some of these, see, it's in these coastal exclusion zones. I was trying to see if we had it somewhere where it's not in a coastal exclusion zone right now. Basically what you do is you just zoom in and then you would see it. See, these places are outside. They're not going to have it. There's not a lot flooding right now, unfortunately. Not sure if it's going to turn on for this little point. It's on a lake. But what you would see is it would just highlight the FIM and then you would play around with it. Let me go back up here real quick and check and see. I'm not sure if any of this is going to be available because it's in the flood hazard zone. And it's not going to show the FIM. But what would happen is this would all be, it would show what's inundated here. But that's kind of how you get to the dynamic FIM. And the same way, right down here is an opacity button, and you play around with that, and you zoom in, and you can see what's flooded for resource management. Maybe there's something that's important that they want to see. And then you would just change your flavor of dynamic FIM right up here. See these three. So yeah, that's how you would see the flavors of dynamic FIM for Vermont once we're under high water. And so again, I mean, I think it's really exciting times for just adding an additional layer of FIM mapping to things, but we've got to be careful on what we're looking at. Messaging is the most important thing, but it's a level of FIM that you haven't had before. So, you come back up here to Vermont and you're going to be able to have it for just some random little creek, some little creek here that's going to be turned on. And you're going to be able to have FIM for that dynamically. And maybe it's good, maybe it's not so good, but we can chat. And it's going to give us a baseline better picture of some of the inundation capabilities in there. So, yeah.
All right. Last call for questions.
Oh, John just put in the map. I see that.
Yeah.
He's got some lists out there. Yes, cat FIM locations. Yep, that's exactly right, John. You found it. And when I turn those, if I turn a few more on in the future, that link, more will light up. So those are the ones that I've turned on right now for our area. There's not all of them. I've turned some of them off because I'm not confident yet. But we will hopefully have more to add going for the future for cat FIM at least.
Great. All right, awesome.
Okay.
Well, I will send the resources out and the recording afterwards at some point by the end of the week. And if anyone has questions, feel free to send them my way and I can always get them to John. And we can always follow up with Darren, who I don't know if was here for the answer to his question, but I'll send him an email. And I put my email in the chat in case anyone needs to reach out.
Right,
Stop this recording though. All right.